Hey everyone, welcome to section 5.2, and in this video we're going to talk about servo motors. And this is just another type of motor at the end of the day, alright? So why are we learning about another motor? Well, there are many advantages to this motor that I kind of want to highlight, so I figured having it in its own video would be useful, alright? So the first one is that it's a very simple way of controlling the motor precisely, alright? So if you remember before, right, with the DC motor, really the only thing that you could do were like spin it really fast, but you couldn't really control the RPM, right? You had to control an analog output, which wasn't really super precise, right? And then you could kind of start it and stop it after a certain amount of time, and you really couldn't control the motor's position, right? How many rotations it spun, unless you added another sensor to the motor called an encoder, but we didn't cover that in that video. We're going to talk about this motor instead, rather. So yeah, it's really easy to control a motor precisely. You actually control a motor based on degrees, right? The amount of degrees that the motor head is spun, which is, super easy to understand, right? You can also easily get the position of the motor. There's no need to wire an additional encoder. And wiring is now super easy. I mean, you only need like three wires. That's it. You don't even need a motor driver. So why would we ever use a DC motor? Well, the answer is, power, all right? So servo motors aren't designed to spin at a super high RPM. So you basically sacrifice the ability to spin quickly in exchange for more precise geared control. All right, that's the main idea. All right, so let's take a look at how it works and wire it up. All right, it's fairly standard stuff. So let's exit out of the motor circuit here. Let's create a new circuit. Let's call this 5.2 circuit. Let's grab an Arduino. It should be fairly standard stuff at this point. And then let's get a servo motor. We're going to be using a micro servo. Okay, so here we have ground. So let's wire that to ground. I'm not even going to use a breadboard for this because you don't really need one. It's only 3 wires. Okay. All right, let's change that to black. Okay, then we have power. So that's just going to go to the 5 volts pin. I'll change the color to red in a second. Okay, and then signal. This is just a PWM pin to control the servo. All right. So pin 3. Okay, and we're done. That's all the wiring. Yep, that's literally it. Okay. So in terms of code, it's a little bit complicated, but we're gonna use a library, so it's actually pretty easy. So let's get rid of this built-in code, and then let's get a library. It's gonna be the servo library. Okay, so the first thing you're gonna want to do is just make a variable that's like the pin your servo is connected to, which in this case is 3, right? And then you're just gonna make a servo object. So servo my servo. Servo is a type, all right? So we're gonna make a servo and we're gonna call it my servo, all right? So then you're gonna do so to set it up, right? It's my servo. So the name that you created here, my servo dot attach, all right? Servo pin. And something to keep in mind, right? You don't have to call it my servo. You can call it like servo 1. You could call it servo if you wanted to. I'm calling it my servo. You can call it whatever you want. All right. This specifies the type, which is a type of servo, right? We're using a servo motor. All right. And then the first thing you're going to want to do after you attach the pin is write it to 0 degrees. Now, write is basically saying specify a position in degrees. All right. And this is basically making sure that the servo starts at ground 0, all right? So basically the position in which the servo starts at is its 0 position, all right? So now, I mean, let's just in setup, right? Since we're already here, let's delay half a second and then tell it to go to 90 degrees. That's literally it. That's all you have to do, all right? So let's start simulation. And there we go. We can see it went to pretty much exactly 90 degrees there. All right, and that's pretty much it. I mean, that's all there is to a servo. It's nothing too crazy. Now, if you wanted a nice oscillating pattern, what we could do is say, all right, let's get rid of this. Let's say I wanted to make it spin between 0 degrees and 90 degrees, right? So we could do my servo dot write. We're started at 0 degrees. Let's wait for a second. And then we do my servo dot write. 90 degrees. We'll wait a second. And then because this is loop, right, it'll bounce right back up to the 0. All right? So let's start. See what happens. 90, 0. 90, 0. I notice this moves a lot slower, right, in comparison to the DC motor, but yeah, that's pretty much it for the servo motor. I mean, the main idea, right, the main principle is that you can set and you can get the position of the degrees very easy. Now, there is a functionality of myservo.read, right? So what you could do is at the top, you could print line that. So if I wanted to print that to the serial monitor, I'd just do serial.begin, 9600, and then you do serial.println. If I did myservo.read, this will print out the position. So if I hit start simulation, I do serial monitor, we can see it's printing out the position. So it's basically just printing out right now every time it goes to 90, if you think about the loop and why that's happening. But if I added multiple printouts after it's being written, then it would be more accurate. But yeah. So, yeah, that's pretty much it for this video. Again, servo motors, really cool for precise motion. For speed, not so much. All right. So thank you so much for watching, and I look forward to seeing you in the next video.